Good afternoon, students.
Good afternoon.
So, in last lecture, we have completed exponents, logarithm, and surds also, right? This part is also covered. And also conversion of log, we have done that also. So today we are going to start with number system. Now number system, here we include binary numbers, decimal numbers, octal number. What are those numbers actually? Decimal numbers means what? The numbers which we regularly represents like 132, 158, those numbers. And what do you mean by binary number? Binary means 2 digits, means 2, anything 2. So binary number means only 2 digits are included. And binary is in terms of computer language. And in computer can understand only 2 numbers. Those are zeros and ones. You will see over here. When we talk about binary number, they are mostly what? Zeros and ones. They will be represented in this form. After this binary, what do we have? We have to convert decimal number to binary number to decimal number. Octal number. Have you heard the term in 11th and 12th? Octane, something like this. So octane means what? 8 numbers. So here you're going to have 8 numbers. But we have to represent it in which form? We will see it later. And hexadecimal means 16. Keep this in mind. Now your first step is conversion of decimal numbers to a binary number. Now for an example from here, should I explain through this part or should I use my method? Let's use my method. See, if your number is 25 and you have to convert it into a binary number, first draw 2 lines. After that, divide it by 2. 2 ones are 2 twos are 4. Now here what you have to do, whatever the remainder is there, you have to shift it towards right hand side. That is in this column. Here 2 twos are 4, so 1 was remaining. I shifted it over here. Again 2, 6 are 12. So 0 came over here. 2, 3s are 6. So again 0 came over here. Now 2, 1s are 2. Correct? But 2 1s are 2. Again 1 is remaining. So whenever you're having 1 to this part, after this your decimal number to binary number will be in this form. You have to start from downwards to upwards. So binary number for 25 is 11001. Let's check the answer in textbook. See, 11, let's say, see over here, 11001. Did you all understood this?
Yes, ma'am.
So you have to represent. See, first it was in decimal, therefore we added 10. But now we have converted into binary number. So to the suffix side, you have to use 2. This was conversion of decimal number to a binary number. Let's take an example from your book. Let's see, 71 is there. Now you have to, sorry, 142 is there, na? Okay. So your number is 142 and you have to convert it into binary number. So just imagine, should I draw the line? So here 2 comes. So I have to divide it by 2. 2 sevens are, 2 ones are. So remaining part over here is what? Now see, here the representation is not proper. Rather than this, we can use my method. which is easier, I guess, to understand properly. What was the number? 142. Again, 2 columns you have to add. 2 sevens are 2 ones are. So here you are going to have 0. Yes or no? Because the remainder is 0. See, 0 came over here. Now after this, again 2 threes are 6. 1 carry over there. 2 fives are 10. So 1 is the remainder still remaining. Again, 2 ones are 3. Sorry, 2 ones are 2. 1 carry over here. 2 sevens are 14. Again 1 comes over here. 2 eights are 16. So again 1. 2 fours are 8. Here now your remainder will be 0. 2 twos are 4. And the last one is 2 ones are 1. So now the sequence will be in which form? In this form, that is double 1. Just cross check our answer then. What should be there? Let me check what happened over here. Okay, now see, I forgot about this term also. Whenever you are going to have 1, if we start from the below part, should it be 1 1 0 triple 1 0? Check over here. Is there a mistake? Earlier some we did it right? It was 1 1 0 0 1. Am I right or wrong? So do you find your change? Yes or no?
Yes, ma'am. Didn't understand.
So here your change is there. Let's cross check this term also. What do you think? What should be there over here? Can you guys tell me? Is it the right one? See, you have done. I told you to be careful. See, here, what did I say? Okay, 2 8s are 16, 1 carried over here. 2 4s are 8, 0 comes over here. 2 2 twos are 4. Why will 1 come over here? It will be 0, right? Because remainder is 0. And then 2 ones are 2. So again 0 comes over here. Understood? In earlier example also we did the same. That's why I have used this method. See, whenever you're going to start, it should start from here. That is 1 triple 0. Now you can check it. Where is the sum? 1 triple 0. 1 triple 0. Triple 1 0. This is how you have to convert decimal to binary. Now let's talk about binary to decimal. Now when we talk about binary to decimal, if this is your number, so your first step will be what? You have to convert it into decimal. So first it was in binary. So 2 is included. Now how many 2's I have to use? 1, 2, 3, 4 and 5. 3, 4 and see. I started, you have to start it from one side only. After that, what they say is, you have to multiply it by which numbers? The ones which are present over here. So here I multiplied by 1. Here I multiplied by this one. Here I will multiply by 0. Then here also I will multiply it by 0. And the last one will be 1. After this step, what they are saying, the rightmost. Now all of you know this is the right number. So rightmost number will have multiplied value of 2 raised to 0. And it will be in an increasing form. 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. Then you have to solve the sum. Now see, 2 raised to 4 is 16. 2 raised to cube is 8, 2 raised to 2 is 4. But I am multiplying it by 0, so it becomes 0. Same way, here also 0. And here we know anything raised to the power 0 is nothing but 1. So once come over here, then you have to add it and compulsory write this suffix side. That is the 10 part because you have converted into decimal. Did you understand?
Yes, ma'am.
Now let's check. Now what is the binary equivalent of decimal 12? 12 will be there. 2 6 are 12. So here becomes my 0. 2 3s are 6. So again 0. 2 1s are 2. But only I have used one number. So 1 is still remaining. Now see, here, do you see similar numbers are there on both the sides? Therefore, at this moment, you can do this part. Understand the difference? 1 1 0 0. So what is your answer? B part. Now let's take the example of conversion of decimal to binary. Let's take this one. So the value is 111 and 0. So 1 is multiplied 1, 2, 3 and 4 places are there. But we started from 0. Do you understand? We are starting it by 0 part. But that 0 is gone to what? To the 0 part because the rightmost number has 2 raised to the 0 power. Here it will be 2 raised to 0 power. Here it will be 2 raised to 1, 2 raised to 2 and 2 raised to 3. 2 raised to 1, 2 raised to 2 and 2 raised to 3. So 2 cube is 8 plus 1 into 4 is 4 plus 2. 8 plus 2 is 10 and 10 plus 4 is 14. So your decimal equivalent number is 14. It's simple, right? Now we are done with decimal and binary number. Now let's talk about addition and subtractions. Now there are some rules we have to follow for binary numbers. So that is 0 plus 0 is what? 1. Sorry, 0 plus 0 is 0, which we know. In addition also we use it that way. 1 plus 0 is also what? 1. 0 plus 1, vice versa. It is also 1. But 1 plus 1, originally, if it was in terms of decimal numbers, it would have been 2. But we are talking about binary numbers. So it is 10. 1 0. But while writing, we don't write 10 directly. What we do, we write 0, that is the right hand side part, and 1 is carried to the next number. Let's take for example this part. 1 1 plus 0 1. So 1 plus 1. 1 plus 1 is what? 10. So I write 0 over here and 1 is carried over here. Now again 1 plus 1 is 10 we know. But according to our method, what do we know? We write 0 over here and 1 is carried over here. After this, we shift this 1 to downside. Then it becomes 100. Understood? Similarly, the other sounds are there for addition. Now let's talk about subtraction of binary numbers. Now there are rules for binary numbers also. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is also 0. See, here some are the logic ones which we have studied, means which we know till now. The difference comes only for 1 plus 1, that gives us 10, and 10 minus 1 gives us 1. Just understand it. Now let's see an example. Again this one. 1 1 minus 0 1. So 1 minus 0 is 0 and 1 1 is 0 and 1 minus 0 is 1. Don't forget to mention this. Now we are talking in terms of binary numbers, so the suffix is 2. Let's see this one. This one looks little bit of complicated, but let's see. Now you have 0 minus 1. What do we know? 1 minus 0 is 1, as well as 0 minus 1 is also 1. Is it or not? Let's see over here. We don't have any such kind of thing, right? So what do we do now? What will we do for this sum? Should we carry the number or not? Obviously, if we talk about decimal numbers, what we would do, we would carry it, right? So we carry from here. So if I'm carrying from this number, this becomes 1 0. Then again I am carrying. Now see, here I am removing again 1. So 10 minus 1 is what? 10 minus 1 is 1, correct? And here then it will be 10. So 10 minus 1 is 1. Again, here, again the calculation, let me solve it properly, then you will understand. See, if I am carrying, it will be 10 over here. I'm talking about this part. So it will be 10. So I need to shift it towards this. So obviously, if it was, let's say, 3 and 2, and you needed one number only. So we would take only one number to this side, correct? Similarly, if I'm doing what? 10 minus 1 over here. So here the value becomes, at this moment, value is 1. If I'm shifting this towards this side, and then 10 comes in between. Here. Understood? When you solve it on your own, you will understand it. So 1 minus 1 is 0. Again, here we had 0. So 0 minus 0 is 1. 1 minus 0 is 1. And 1 minus 1 is 0. Below they have given you how to solve it. Now octal number system. Octal, I told you. Octal means what? It starts from 8. Sorry. The base value for it will be 8. So whatever the multiplication, whatever the division you are going to do, here your divisor will be your 8 number. So here the digits are from 0 to 7. See, we started with what? 2. 2 because binary number was there. So it started from 0 and 1. Only 2 digits were included. And when it comes to 8, so it will start from 0 to 7. Because till 1 to 7, there were 7 digits. But we have included 0 also in our octal number system. So there are 8 digits in total. Now let's take an example. Conversion of a decimal number to an octal number. So this is your example, that is 25. You have to divide it by what? We are talking about octal numbers. So 25 is divided by 8. So 8 fours are or 8 threes are. 8 fours are obviously 32. So we have to go by 8 threes are. 8 threes are 21. So 1 is remaining. After that, can I do 3? 3 ones are 3? No, because we are talking about 8. So we have used it. So my answer is octal number of 25 is 3 and 1. See, 3 and 1 and the suffix is used 8. Understood about decimal to octal. Now let's talk about octal to decimal. So 31 into the suffix of 8 you're having. So we are talking about octal number. So you need to multiply it by 8 plus 1 into 8. And what is the thing for binary? The outermost, the rightmost number should have raised to the power 0. Same way around. Check over here. It is the same thing. This will be your octal number to decimal number. Now let's take an example. What is the octal equivalent of decimal 12? What will it be, students? 12 is there. So 8 ones are 8, correct? So 8 ones are 8, so it will be 4. So your value will be 1 4. So this is your answer for it. Now decimal to octal we will see. We will take a short number 110. So 1 into 8 plus 1 into 8 plus 0 into 8. But the rightmost power should start with 0 power. And this 8 twos are, will it be 8 twos are? No, it will be 8 raised to 2. So 8 square is 64 plus 8. 8 plus 4 is 12. 1 carry over here. So it is 72. So your answer is 72. This is how you are going to solve the sums. Now we are going to talk about hexadecimal numbers. Now hexadecimal stands, the base is equal to 16. So here we not only include the digits, but we include our alphabets also. Now how do we do that? Originally the digits are till where? 0 to 9, right? After that the numbers are in double numbers and they are repeated form. Correct? 0 to 9 is the original number. After 1 0, this is what a repeated form type. So till 0 to 9 we use these digits. After that we name alphabets. A is considered as 10, B as 11. Till where we have to go? Originally for octal it was 0 to 7. For hexadecimal it should have been 0 to 15. Okay, are you understanding this part? But till 9 only we know. So we have to start with alphabet and end towards F, because F has the digit value as 15. You can see over here, they have given us. Why we are not taking 10 as a separate number? Because it will be difficult for us while solving the sums. Because in this part, that is this one part, here how will you write 11? How will you write 10? Therefore, instead of 11, you are going to write B. Instead of A, you are going to, if instead of 10, you are going to write A. Understood this part? So let's see example. Conversion of a decimal number to a hexadecimal number. The first one only, 25. If you have to divide it by 16. 25, you need to divide it by 16 because we are talking about hexadecimal. So 16 twos are, you can see it is 32. But so we need 16 ones are 16. So 25 minus 16 will be 1 carried over here. So 9 is there. So originally we can write 9 as it is. So hexadecimal for 25 will be, let's check it. It is 19, correct? 19. Now let's see something related to ABCD. Which number? This one looks a little bigger number because we need to divide it by 16. Let's check from here. So if this is your number, that is double two. No, let's take it from your example, so it will be easier to you. Now conversion of hexadecimal number to a decimal number. If this is your number, same way, the same method where you used for binary number. 1 is multiplied by 16 plus 9 is also multiplied by 16. But the rightmost power should be raised to the power 0. And here it will be 1. Correct? But anything raised to 0 is 1. So 16 plus 9 is nothing but 25. If you have to cross check it, you can see the hexadecimal value is 19. The decimal value is 25. An earlier example which we solved over here, the decimal value was 25 and the hexadecimal value is 19. Did you understand this part? Now let's take the example. See, what is the basis for hexadecimal number system? Obviously 16. Which of the following is not a valid hexadecimal number? Now, how do you find it, whether it is valid or not? What should be a case now? You have to understand it. Which number should we take? See, here the values are in terms of BA. Let's take this one, 59. It is a smaller number also. So you can do the calculation over here or else your mind calculation. Now 16 twos are 32, correct? So 16 threes are what? 6 threes are 18, 1 carry over there, 48. So probably we are going to need 48 only. But let's say 16 fours are. 16 fours are 64, right? So we can't use it. So we have to use 16 threes are 48. So 59 minus 48 is 9 minus 8 is 1. 54 is what? 1. But 11 stands for 10 stands for what? A. So obviously B. So your answer is 3B. Understood? See, I am trying to show you because otherwise I could have done in the simple way. So this all is there in your syllabus. What all did we study? We studied decimal to binary, binary to decimal, again addition and subtraction of binary. After that, decimal to octal, octal to decimal. Again, the last one is hexadecimal to decimal and decimal to hexadecimal. So the method which we use are the same for everyone. Now let's take conversion of hexadecimal to decimal. Now which number? Let's take 80. Now 8e. So 8 is multiplied by 16 plus E stands for what? F is for 15. So obviously E is for 14 into 16. So 16 raised to 0, 16 raised to 1. 6 8s are 48 now. So 4 carry over here. So 128. Anything raised to the power 0 is 1. So 128 plus 14, 12, 3 and 4. So 142. So this is your answer. This is how you are going to solve it in your question paper. Now after this, how many units do we have in this? Okay, there are much units. So we have to move it further. Now let's further. Till 11th and 12th we studied permutation and combination. What does a permutation and combination mean? We know the formula. NPR equals to n factorial upon n minus r factorial and so on. But what do you mean by permutation and combination? Permutation stands for arrangements of letters. Here, the main concept is if you're placing A on first place, it should be on first place only. You can't shift it towards the second place. But combination means what? Here you need to select, you need to choose whether it may be letters or numbers or balls or men and women or so on. So, did you get the rough idea of permutation and combination? Yes or no?
Yes, ma'am.
So, when we talk about permutation, the first thing, we need addition principle and multiplication principle. When do we use both these principles? Now see, addition principle is used when two sets, or I can say the elements under which two sets are there, they should be disjoint. Now disjoint means what? There shouldn't be anything common in between them. See, if A and B are two finite disjoint sets, then the number of elements in their union, that is A. Now see, uh, Abhilasha, we talk about the sets and relation, right? I asked to one of my colleagues, she told me that there we can't do anything because the symbols are missing, right? So from that, you need to choose the correct one. Now we know the distribution formula, correct? So if the symbols are missing over there, we need to add it on ourselves and tick mark it, the
I
correct
did.
one.
I did my own. I just
That
asked you two questions about, but you solved the one, and
okay.
other one I solved on my own.
Okay. What was the second question?
Uh, Actually, I don't have my book right now.
Okay.
Yeah. So let me check in the drive. Last.
Let's start over here then.
Okay.
So addition
I'll ask
principle.
you later on, ma'am. Okay. Is it?
Okay, okay. Whenever you're having the book, you can ask me.
Yes. Thank you.
Because see, in this case also, here they have used I symbol, or sometimes they have used this symbol. I don't know means what is the meaning over here, but still, let's say, see, here you need to understand now. Here they have used this symbol means you have to multiply it.
Yes.
Understood?
Yeah. But most of the symbols are missing, ma'am, in complete.
Yeah.
So this
We
is
can't,
difficult. I can
yeah.
understand set on my own, but other subjects I don't know, or other chapters of maths.
Till now, only sets have just means it has most problems, right?
Yeah.
Now here though I have cleared you because I have
Yeah.
solved the
I
sums
understand
only.
that. That is the multiplication sign.
Right. So
Yes.
it's no problem till here. We will see
No,
later.
no.
If we find difficulties, we will change it by ourselves.
Yeah. Yeah.
Now, when union comes, at that time you use and, that is plus sign. And when here see, now here they have used multiplication when if two finite sets, the number of Cartesian product. Now see the difference. Here they have used Cartesian products. Cartesian means cross sign. If you remember,
Cross.
vectors, cross sign
Yes.
was there. It was not a normal multiplication for us.
Mm.
When we solve the examples, you will understand it. And do you all know factorials? I guess you should, means
Yes,
you
ma'am.
know that let's say a number is there, that is 3 factorial. So your last number should be running through 1 and it should start from 3. After that, you need to minus 1 from that, and after that, you have to minus till where we have to go, till your last digit is 1. So that is nothing but factorial. Now let's see the permutation part. Now this, see, all of this thing is you can read it on your own. I'm just giving you a hint what happens over here. Let's take an example from here. List all possible arrangements of the word ONE. Now this was 3-letter word, so arrangements will be 1. So after that, I'm shifting E to the second number. It will be OEN. Then I'm shifting it to the first, so it will be EON. So E part is done. Now let's talk about O. O is at first position over here. Then O will be at second position, and the last one will be at third one will be at this position. So O is also done. Now let's talk about N. Here N is at second position. So I need N at one position. Let's take this one or this one, whatever. And the last one at the third position. Correct? So how many arrangements will we get? 1, 2, 3, 4, 5, and 6. Okay. The other way around, if see, if in your this question they have not mentioned that there is repetition or without repetition, you have to consider what there is without repetition for sure. Now they are saying list all possible arrangements. Oh, okay. So this place has how many numbers, means how many elements? One time O will be there, one time N will be there, and sometime E will be there. So there are 3 places, correct? We have placed 3 places over here. After this, now over here, if I'm using O, will I be using O over here? No. So how many places are there for this number? You have to minus from here. So it is 1. And the last one will be 1. This is how you can find the answer. The other one is by permutation method. Now there are how many letters? 3 letters. And how many arrangements I have to do? 3 arrangements. So 3p, 3. But what is 3p3? That is the remaining part. For that, we need over here. Now, for given n objects, to be more specific, n should be different objects. And we have to select r objects from that. At that time, we write npr. What is the formula for that? N factorial upon n minus r factorial. See, here your minus sign is missing. Kindly write it down. Now, how do we get it? See, you're choosing NPR, correct? So NPR means n into n minus 1 till where we go? Till n minus r plus 1. See, the plus 1 is always there at the last moment. If you go from this method, you will understand how it came. And the last product which we get is n factorial upon n minus r factorial. Should I read it out? See, if you're having n distinct objects, you need to arrange them in row. Now here you only have row, it's fine. But if you had circular, it will be n minus 1 objects. Then we have n places, correct? There are nth row, so nth places will be there for first one. Then n minus 1 places for the second place. See, earlier example, 1. O, N, E. Here it was 3 places, here it was 2 places and 1 places. Now, if let's consider this as n. So this will be the second place will be having n minus 1 place, and the next one will be n minus 2 place. But see, to be more specific, your last place is what? 1 over here, correct? So your selection should go up to what? 1. Understood this part? This was selection of what? N distinct objects to be arranged in row for the nth place. The third place, correct? This was a third place. And your n is what? 3 over here. So nth place you had 1. Same way, again from this formula, the nth place will be 1. Then this is called as permutation. Now out of this, you need to only arrange R objects. Here we arranged only N objects. All these objects are included. Not only this, the other ones also are included. Now we need to select from this only those which contains R objects also. So the first position will be for N. The second will be for N minus 1. Up to till where it will go. We have to select R na. So N minus R minus 1. Now R minus 1 stands for what? It will be for the rth position. And therefore, this is nothing but N minus R plus 1. Okay. So can I name this as N minus R plus 1 factorial? Obviously, you can see. So the number of arrangements or permutation of n objects taken at r time. So n minus up to till where n minus r. So obviously n is, you have to select r objects. So this will be the formula. And how do you derive it? So this 1. Now what do you stand by 1? Into. Why did I took this sign? Because I can cancel it down. So the remaining will be n minus r factorial. Understood? Now let's take example of it. 1 is done. Now let's talk about, should we talk about combination now? Only 2-3 examples are there. See, English, what is the number of possible passwords for a computer if a password must contain a sequence of 5 letters from English alphabet? Now password should be of how many forms? 1, 2, 3, 4 and 5 letters. Okay, and it should belong to English alphabet. English alphabet means 26 alphabets are there in total. What you can do is 26p, how many I have to select? 5. Done. And then substitute into the formula. Otherwise, if you want to cross check, you can use this formula. In first place 26, in second place 25, into 24, into 23 places. See, this one is a little lengthier one, I guess. This will be a simple person because the answer which you're getting is in lakhs. So it's better you use this formula. A debating team consists of 4 boys and 3 girls. Find the number of ways they can sit in a row. Now see, they have not mentioned how you have to select. They are saying only sitting in the row. In total, how many are there? 7, na? 4 plus 3 is 7. So how many places will be there to sit in a row? 7 places. Done. And there's one more thing. The value for NPN will be always be n factorial. Don't forget about that. Now let's talk about combination. Combination means what? Selection. What is the selection? Let's see. How many ways are there to select 3 different letters from the set of letters A, B, C, D? Now see, you just need to select. They are not saying A should be placed at first position. So you can either take ABC, you can either take BCA. Now here, see, they have given below only. ABC, BCA and ACB. So these selections are what? So here, all of these selections means here it doesn't matter whether it is on first position or second or third. So all these three selection are considered only one selection. Understood? Only one selection they have considered. See, ABC, BCA and ACB. Same way, if you need to find what are the correct ones. So those are ABC, ABD, ACD and BCD. So there are only 4 combinations. Did you understand? For 3. Now here you need to select. Directly they have given you the formula. N objects are given. R objects need to be found. So the formula is n factorial r upon r factorial and n minus r factorial. Now how will you do? 4 select 3. See, let's cross check through this example. 4C3, 4 factorial, 3 factorial and 4 minus 3 factorial. So factorial, 3 factorial, 4 minus 3 is 1 factorial. So 4 into 3, 3 factorial, 3 factorial, these get cancelled. So you're going to have 4 over here. Now let's talk about combination properties. What are those? NC0 is 1, NCn is also 1, NC1 equals to n, NCn minus 1 is also n, NCr and NCn minus r is also equal. And don't forget about this formula, that is NCr plus NCr minus 1 equals to n plus 1 Cr. Now let's take an example for it. Now here they have done a mistake. What is the mistake? Let me tell you. If a group of 30 people have been trained for a particular computer software project, how many ways are there to select 6 people from this group for advanced training? So what should be the answer? 30 people you have to select from how many? So 30 is 6. So this is the method, but they have given 20. So don't just copy it down. It should be 30C6. Now let's take another one. How many ways are there to form a community for from? Now in total they have given us a. So how many men do I have? Those are 4 men and 6 women. And community should be of what? The first case is what? At least there should be 2 men and at least twice as many as men. So tell me, what should we do? So minimum, the first case for us is what? It should start from 2 men and ends towards 4. Obviously we can do that, right? But the minimum case is, now see, here you're going to have cases. Let's go by cases only. So your first case will be what? And at least twice as many as men. So if I select the first case, if I take only 2 men, okay. So at that time, how many women will be needed? How many women do I have? 6 women do I have? Correct? They are, have they told us how many ways are there to form a community from 4 men and 6 women with at least 2 men and at least twice as many as men. Twice, see, at least twice as many as men. Men are, if we take men as 2, so twice the number of men is 4. So women will be how many? 4. Don't forget about that. So 6, 4. This is my first case. In second case, 4C3. I am taking 3 men. We have to start it from 2. So 3 men. The twice the number of 3 is 6. So C6. Will it be 6 now over here? Yes or no? Yes or no?
Yes, ma'am. Yes.
So this case is also done. Don't look at the question because I am going randomly. I am finding it. After that, what is remaining? What is remaining now?
2 men.
Can I take 4C4? No.
No.
If I take 4C4, the value will be what? 4, double of 4 is 8. But
8.
in total, I don't have 8 women, na? I only have 6 women. See, 6 women are only there. So the total number of 4 is what? 8. So I can't take that. See, according to this, now after that, where is the question? Our question is here, na? Okay. So how many ways are there to form a committee from 4 men and 6 women? At least 2 men we have taken, na? So for this condition we have done at least twice as many as men. So we need to start it from 4, but still 5 is also remaining, right? They are saying twice as many. So if I am starting from 4, I need to add which terms now over here? 4C2 into the next number for it will be C5, and the last one is 4C2 into 6C6. Did you understand from where this term came? There they
Yes.
have said at least. If they have said, where is the question? If they had used only what? Twice as many as men, only this condition would have come. They have said at least. So minimum, you need to start it by 4. But you can increase it. Till where? 66. Only 6 women are there. But we can't go for 4C4. I told you the reason behind it. Because the bigger number for 4C4 is, for 4, the double number is 8. So 8 women are not possible. So only 4C3 we take. Understood? So all of these cases. Now there's no connection in between. So don't forget about this. See, this is some kind of trick for me also. Whenever you're having cases, you need to add all of these cases. And when we talk about the arrangement, there you need to multiply. Don't forget about this. Here you need to multiply, and when you're having cases, you need to add it down. Understood? When you solve the sums, it will be easier to understand. See, they have done the same thing. They have added down. So we have completed permutation and combinations also. Try to be with my speed only. Try to cover, because see, only 1 to 1 2 exercises you're having. Try to solve daily one self unit test, 5 questions, 5 questions, 5 questions, each of the terms. So you won't need to memorize during your exam. Understood till now? Yes or no, students?
Yes, ma'am.
Any doubt?
Ma'am, the Cartesian products in the sets. The 10th question I was asking about yesterday
Okay,
lecture.
okay.
Yeah.
The Cartesian product. Where is it? This is log. Okay. Which one you are talking about, dear?
I'm Cartesian. Yeah, that is the 10th
R to
question.
R, na? What will it be? You tell me
Um, Ma'am, the
from
answer
this.
is 1112. This can also be, but the symbols of missing from B and D. So I am a bit confused.
Okay. Now see, X should belong to R and Y should belong to R. Can we use this then? Yes, this part we can use. Because see, X values are for or from all the R real numbers. So there will be minus sign also. Why I'm not talking about this? Because this symbol we don't know, right? What does
Yeah.
this represent? So
Yeah.
better we use this only, no? Correct? Because X belongs to R and Y belongs to R. So our sum is done over here.
Yeah. So the answer is D.
Yeah.
Thank you.
Should we end the meeting then?
Okay.
Thank you.
Thank you.